All right, we are going to finish up our last questions on our measurement materials safety practice test. And then we are going to get out to the shop. And so before we get out to the shop, I want you guys to be thinking about a couple things. When you are making your parts, you have a ton of time to make these parts. And I think the thought is, I'm gonna make this part as fast as I can, which is a good thought, but it's not always super beneficial. So this is Allie's part from yesterday that she turned in. This is trash. Okay, so it's okay to have trash. 101, this is the time for us to figure out where our problems are at, okay? So, most of the holes in the hole locations look pretty good. If you will take a look at it though, I'm not so concerned about where things are at, but some of the tapped holes are in crooked. So they're kind of going, like from this view, they're kind of going up this hill. And so it's not going in straight. And then this, this hole that doesn't go all the way through, I think that probably there just wasn't quite clarity on the hole here. Because I saw somebody else do this, and so I'm going to flip out of this for a second, and I'm going to go back into this part, and I believe that it is here. Let me zoom that thing up a little bit. Okay, so this is the part, and here's where I think the real problem happened, is one, the tapped holes, if your tapped holes aren't straight, it's because you were not using the tap guide that you already made, okay? So the tap guide will help you get things lined up, so you set the tap guide over the hole, it'll help you get lined up, and then you can just run the tap. Because what happens when you're hand tapping, you've probably seen this, it kind of starts to do this, kind of starts to wobble around, and then not only does the hole go crooked, but it gets bigger. And so then the bolt, we don't want the bolt to be, you don't want to be able to throw the bolt in and have it sit in there. You want to be able to, for it to be nice and tight. Now this hole, this last hole, this is the hole that I've seen several people have a problem with already. This hole is probably the most difficult part on the entire part. If you'll look at how deep this hole should be, it should almost touch the bottom, okay? What I think that you guys are doing is you're seeing 5/16, 375 deep. And so you're drilling it 375 deep. What it's saying is 5/16 deep, 375 max full diameter. That means it needs to be 5/16 full diameter down 375. So our part is ½ inch, right? So that means our hole, the diameter of this hole needs to be 375 deep, okay? So little shovel symbol. So then that means we actually need to drill deeper than the hole. How much further do we need to drill deeper than the hole to make sure that we get the whole depth for that 375 deep?
You told me like 400.
Okay.
But I mean, I guess it depends on the drill.
It depends on the drill point.
Yeah.
So if the more pointy the drill is, the more of a chance you have to break through. There's a pretty simple way, and we'll get into more depth into how to do this, but just the simplest way is to take the drill diameter, so 5/16 times 0.3 equals the drill point depth. Alright, so it's 5/16 times 0.3. We got one lone calculator person. What's the decimal equivalent of 5/16? Eden, what is it? We got time. Because that's really the first thing that we need to know.
These questions are just so funny, I don't know what to do.
Okay, 312, right? So 5 divided by 16 will tell you what that is. Or maybe you got a fraction decimal conversion on your calculator, or you can always look on one of the charts. Nothing wrong with looking at a chart. So 312 times 0.3 equals 112, 111?
I got 0.093.
0.093, okay. 0.093, so about 100 thousandths deeper. So we're gonna go 312 plus 093, or I'm sorry, 375, our depth here. So 375 plus 0.093 is what? Allie, what is it? Oh, go ahead.
468,000.
468. So that means you have to drill to point to the tip 468 thousandths in order to get that 375 full depth. Now you can check that after you drill it by running your scale, depth micrometer, edge of your calipers down here to make sure that you get a full 375 deep of diameter, okay? Then, the taper that you put on there, it should be 82 degrees. And so it should come out to a 1/2 inch diameter at 82 degrees. So it cannot be a center drill, it's gotta be an 82 degree countersink. Okay, countersink is different than counterbore. So that means that you would check that here at 500 thousandths diameter or 1/2 of an inch. Okay, so this is too deep on the countersink, it's too shallow on the drill, so it really leaves room for no threads. And you can't thread this with a normal tap. Okay, you have to use a bottoming tap for it. I don't know if Clint showed you a bottoming tap yet, but I know there must be some out there because we used some yesterday. The bottoming tap, so taps are kind of built in 3 different categories, roughly 3 different categories. You have a tapered tap. Let's just look at.
Hole's 80 thousandths too big.
Your hole's what?
80 thousandths too big.
That could be part of your problem then, right?
I designed it at 1.3, which is where I need it to be.
Right. So that's fine. But yeah, just there's.
I wonder what caused that, like offset error or.
Were you in where? Three major styles of taps that we can use. A taper tap. Taper tap is for something that's going to go all the way through something. Because the front of this tap you do not develop full threads from. Okay, so it's like if you're hand tapping something and you got to go through 1/2 inch plate or something, this gives you a nice slow start so you can get through there. Plug tap, you're losing about the first 3 to 5 threads are not full threads on it. So here at 8 to 10 threads, you're losing 3 to 5 threads. You're losing. That's probably a standard machine tap that almost everybody uses. Because you can kind of modify this tap into be some of these other taps, they'll work for other taps. What you need for that particular hole is called a bottoming tap. That bottoming tap, you only lose about 1 to 1.5 threads on the bottom. So it's shaped differently. It's got full threads, so you can see long point, not as long point, hardly any point at all. that's the kind of tap that you need to use on that particular hole. So that hole has some 3/8/24 threads maybe, or it has some fine threads and some coarse threads on it. This is a coarse threaded bowl, so it's a 3/8/16, but it's gotta be a 3/8/16 bottoming tap, okay?
You just gotta be a little more,
Oh, fine threads, quarter 28.
you just gotta be a little more careful when you're starting the tap.
Yeah, so the bottoming tap doesn't have as much taper to it, but again, if you're using the tap guide, it's gonna line your hole up and you can run that thing straight through there. Everything that we make is for a reason, okay, at this point. You will make widgets later on. But right now, the tools that you're making are tools that you should be using for the next operation. So you made a tap guide to guide the tap, you made the tap handle to hold the tap to guide the tap, right? So now the drill press project is your real first widget, it's your first thing that means nothing. Your vice jaw is a thing that goes in the vice so that we can use it within other classes. So, all of those things have purposeful meaning. There is nothing wrong at all with being like, hey, I think my part sucks, can you help me figure out what I did wrong and make a better one, okay? You have no frame of reference, or at least we don't expect you to have any frame of reference to make sure that you have a good part, okay? So like we don't think that you already know what you're doing when you come in here, so we're expecting you to be like, I'm not sure how to do this, what do I do next? It's okay for you to do it wrong, and then to come back and be like, hey, I need to do this right, do it again. This is a piece of material that costs maybe $1. You can, like, please don't go into Drill Press Factory. Okay, I don't wanna see Allie having like a stack like this tall of them and go, I've got 20 of them, could you grade these and take the best one of all of them? I don't think that she'll need to do that. I think that she's gonna remake this one today, she's super fast anyways. She'll remake this one today and it will probably be splendid. The only other problem that I really saw in this part is at the bottom of this counter bore, there's chatter. That happens because you've got so much effective area of the tool touching at one time. The larger the area that it's affecting, it's going to cause some type of chatter or vibration. The easiest thing to do is adjust your RPM on these things, okay? So two different things can happen in that. When you get to the bottom of the hole, if you're using a stop, let it sit there for a second and dwell. Another way to do it is since on the drill presses they have variable RPM, so adjust that RPM. The RPM slowing down or speeding up, so not super fast, but slowing down or speeding up, will oftentimes remove the chatter that comes from there. You want a nice smooth bottom on there. Nobody wants a bumpy bottom, okay? So you want a nice smooth bottom on that part. All right. Allie, I'm not trying to pick on your part. I'm just honestly. Everybody's look like trash. Yours, not everybody's look like trash. Most of them look like trash. Yours just happened to be the one that I saw and was like, we need to look at some stuff. So, it's not that you suck, it's that everybody sucks. I don't know if that helps. Yes.
Pocket did not have a wear option.
Okay, you should have, on that part, you should have done a pocket, left yourself some stock, did a 2D contour for your finish pass. And then that would have given you the ability to have some fine tuning.
So how much should I move my draw forward and my Y back if I'm 88 thousandths big?
Okay, that's what you got, right? It's 44 thousandths too big there, right?
Yeah.
So that means you've got to come up in Y at least by that much. Right? So you got to come up 44 thousandths in order, at least, I would probably just round it to 50 thousandths to give yourself some room. So pull this jaw up here. Move your Y from where it was here to like up here, so that you're milling your hole See what I'm saying?
Kind of.
Well, you gotta shift up, or else you're not gonna clean up.
How much do I shift up that bottom jaw quite a bit?
1/8 inch, 1/4 inch. So if you were using a 1/2 inch spacer before, is that what you're using? So like maybe use a 3/8 or a 5/16 spacer now. Okay. Anybody get started drilling on the vice jaw yesterday, or the vice jaws yesterday? Who got them laid out? You got yours. Allie, you get yours laid out? Nobody else? Okay. What is, we'll start here and we'll go this way. What is the measurement reading on the inch vernier scale, or 26?
Supposed to be here.
Yes, you. He's in a different class. He just happens to be in this classroom.
I got it.
Yeah, I feel like maybe we should incorporate them into it.
So, do I need to do any stock to leave in my radial or just axial?
Oh, no, sorry.
Yes. Yeah.
Checked up.
Okay. Yeah. I think you're right. Just radial, not axial.
Okay. When do you use it in radial?
No, you should leave it in radial, not axial. Axial would be if you want to leave it in Z. You don't want to remow the bottom of it. Okay, so we're at 400, we're at 425, and then we've got an additional, let's see, 5, 6, 7, or sorry, 7, 6, 7, 8, 9, 10. We said 429. I don't know, that might even be my fault, just a little bit short of that. I actually might call it 425.4. So there's 425, and then actually I think I'd call it 425.4, not 429. On this 10th scale, so 400, 425. The line that lines up closest is this 4 right before the 5. So 425.4 on that one instead of 429. Instructions for proper machine maintenance can be found where? SPC chart, statistical process control, nope. MSDS, maintenance manuals, none of the above. Where would I find instructions for the proper maintenance of a specific machine? Maintenance manual, thank you.
Was that other option on that last question actually on there, or was that just?
It was on there.
Oh.
This one.
We got a better look at it just to
Yes.
understand how.
So we are 400, we're 425, and then we are 1,
And 4, yeah.
2, 3, 4, yes.
Okay.
3.5 inches.
3.5 inches, yeah, that's the toughie right there. I'm gonna skip through a couple of these other ones. Not this one though. Skylar, what's it read? Might need to get up there and see it.
672.
672, correct.
On my 2D contours for the finishing pass, should I put the compensation type and wear on that one then?
Yes, and then set yours to 0 out there on your diameter.
Okay.
And then if it's small, then you comp it out.
I left 10 thousandths for stock on the pocket.
Okay. Allie, what's that say? Huh? Come on down. That's right. .4. Good job. Never leave a chuck key in the machine, true or false? Have we experienced that already?
I've heard of them,
Yeah.
Yeah.
Yeah, somebody did.
Who did it the other day?
I don't think he's here.
Who was it? Chance? Yeah, I could see that. Yeah, and so that absolutely happens. I mean, obviously you saw it. Another thing that you wanna watch for is you wanna make sure, and I know this sounds super obvious, but when you're trying to learn something, obvious things sometimes go out of the way. When you're turning the machine on, you need to have the chuck key not only out, but your hand away from it. Okay, so here's the scenario. Chuck key is still in your hand. You're so excited to turn the machine on that you turn the machine on with your hand on the chuck key, and it swings around, hits the lathe bed. I literally know a guy, actually, believe it or not, my wife's brother, my brother-in-law did this, when he was in high school here. He had his hand on the chuck key, in the chuck, turned the spindle on, it swung around, hit his fingers between the chuck key and the lathe bed, and it popped the end of 4 of his fingers off, and it just goes, blood just comes out of it. Thank you. It's a fancy piece of tape. It's nice.
I can't get regular people now, so.
Yeah, that's fancy. Okay, Victoria just brought this in for us. We're gonna have, spring enrollment, walk-in enrollment for you guys in IEM, November 4th. 9 to 12, and then 1 to 4 in Victoria's office. All you gotta do is go in there, sign, go in there, sign, okay? Easy, easy, easy. Just gonna leave that there. Okay, this we'll just do random fire. Okay, common cause for injury when using a hand file is which of the following? Allie. How do people get hurt the most when filing? 39. So all of those are ways that you can get hurt, right? But what do you think would be the most common one? What? No handle, absolutely. Lots of times people will file without a file handle, and you got that tang that comes off the back of it, it's kind of pointy and sharp. We don't do that, your file should come with a handle, but in case the handle comes off, don't be like, oh, I'm just gonna do this real quick. Honestly, real quick, motions like that are great opportunities to have problems. Stop, put the handle back on there, it either goes in with the taper or some will have a little collet so you can put in there. But take the time to do it the right way. 41, this is for anybody. Which type of classified metal does not have any iron as a basic ingredient? Ferrous, non-ferrous, high temp, or rare? What?
Rare.
No.
Non-ferrous.
Non-ferrous. Which of the following steels has the lowest carbon content? Metrology people should know this. 1015, 1018, 1025, 1045. 1015. The 15 determines the amount of carbon that is in it. Okay, so those first 2 numbers are alloy, and the last 2 numbers are carbon content. It's got to have at least point what to heat treat? 0.3. So it's got to be at least 1030 and for it to be heat treatable.
So you can't just heat your iron, like.
You cannot just heat treat a piece of iron. No. Oh, here is a great question. How many standard precision gauge blocks must you stack for an accurate reading of 3 inches, 687,005 tenths? you will not be able to get that probably from just looking at this. So you're going to need to either, it might be in your textbook, it will definitely be in the machinery handbook, okay? So gauge blocks come in sets. 81 or 88, I think, is a pretty standard gauge block set. So grab a book, you can look in your textbook, or you can look in a machinery handbook, to see what you got. And I will see if I can't find it as well in the textbook. I know that I can find it in the handbook though. Anybody find it in the textbook?
Look on 108, 109.
109, yeah, absolutely. So 109, figure 2.4.25, block sizes of an 88 piece inch-based gauge block set. Now the machinery handbook doesn't have it listed like this. What it says is there are X amount of gauge blocks from 1 inch to 2 inch, X amount of gauge blocks from 0 to 50, or from 50 to 100, and so it doesn't give you a specific listing of all the gauge blocks. Alright, so how many gauge blocks do we need to stack up in order to get 3 inches, 687 and 5/10? What's one that we know we're gonna need?
3 inch.
3 inch. So 3. What is another one that we would know that we would need?
Probably 650 pounds, or just 600,000.
Is there a 650?
And the chart says there is, yes.
Okay, so if there's a 650. So we're getting closer. I think we overshot it though. We've got to get this 5/10 in here somewhere. Actually, we've got to get this 7,500 in there somewhere. That's where I think the problem's gonna come in. Yeah, feel free to use your resources, use the whiteboard, add it up on your little, right in front of you, add it up on your calculator, pencil, paper, you can cut your finger and write it in blood if you need to, don't do that. But you can do lots of different things in order to get that. Eden, what do you think next? Are you looking or just staring, hoping that somebody else will get the answer?
It was kind of like 0.145 maybe,
What's that?
maybe like 0.145 in it.
145,000? Instead of this or with this?
Instead of that.
Okay,
Do you have any gauge blocks that have a half tank?
have a 5/10. So it's probably gonna be a 100 and 5/10.
Cause I've never seen one, I don't even have any to work.
I mean, a 5/10 gauge block would be, you could see through it. It would be so thin. So yeah, you're not gonna, 50 thousandths is the smallest gauge block that's in a set, I think. So you said 450 what? Did you say 450 something?
0.145.
0.145. Okay, so Eden says 0.145, so 3.145. So he's getting us closer. Is that the direction you need?
Probably go ahead and slap the 105 10 thousandths on there.
I think that's a really good idea. So 105/10. That kills this one, and that kills that one. So we need to come up with 687 thousandths is all we have to come up with, or, not even really that much. So at this point, we have 3 inches, 245 thousandths and 5/10. This is just adding, is all it is, but the only problem with the adding is you have to work within a set of numbers. You gotta get a 7 somewhere.
I was thinking we add a 143 to it.
A 143 with this one?
I'm trying to. Yes, and then we add another 300 thousandths and we'll be there.
Okay, so we go 143. And then you said, tell me the other one.
300 thousandths.
300 thousandths. So add it up, 3 inches plus 145 plus 1.005 plus 143 plus 300. I think you overshot it.
Yep.
How much?
1,000.
By 1,000, so that's an easy fix, right? So we can take probably one out of here.
Oh, I'm gonna say 142. It's 5 is 3. I'm trying to make 7.
When you said that, I was like, that's 8, not 7. Okay, so you can do it with 300 or 3 inches, 145, 105/10, 142, and 300. So that's 1, 2, 3, 4, 5. That's 5 gauge blocks. Could you do it with less than that? I don't know if you can or not. I think you could do it with other ones, but I think you'd still probably end up with the same amount of gauge blocks. So I think 5's the right answer on that one. That's a fun one. We should just do those every day, shouldn't we? Alright, let's ask one more gauge block question.
I only got it in 6.
You got it in
I
6?
didn't narrow it down to 5, or I didn't have the time to.
Oh yeah, we're starting running out of time. So now this is outside of the questions. When you stack up gauge blocks, okay, so gauge blocks are like this if you've never used them. And if you've never used them, we will definitely get a chance to use them. There's a set missing out here. So this is what gauge blocks look like. Okay. Has anybody used these before? One. Okay, yeah, I'm in trouble. So we will stack up some gauge blocks and get them to the right setting. When you're stacking up gauge blocks, you want to make sure that after you stack them up, you take some calipers or micrometer and measure them just to verify, because if you don't, 2 things can happen. One, you could have grabbed the wrong gauge block in there and you might think that you have the right dimension, but you don't. So you want to put the micrometer on there. Also, you want to make sure that they are tightly rung together. So the process of ringing them is on the next page, I think. And so it's just that process of they're so flat that when you put them together like this, they should hang out. So this is just air. We've pushed all the air out from in between them, and so now I can pull them apart. Okay, so they're not magnetized, but what I can do is I can twist them or ring them together in a way that they will just hang like this. Okay, that's how you know that this dimension should be 4 inches, 950 thousandths. If it's not like this, if I just put it together like that, it's probably more like 4 inches, 950 thousandths and 5/10, because it's not smashed down that last half thou. So we want to make sure that those are out in order to make sure that we've got a really good ringing, so that our stack of gauge blocks comes out to the right stack. Okay, let's do this. let's go ahead and stop here. We can, Clint, when he gets back, he can pick this back up with you guys. You guys have some other stuff to do too. Who thinks that they need to redo their drill press part? Ellie does, because she got picked on. Alright, if your part is not what you would call good, okay? 50% of your grade is based upon projects, okay? There is a low bar that we've set for 101s, but the bar is not non-existent, okay? So you can't just turn in anything and get 100% for it. Oftentimes what we do is we wait and collect the best ones. The best ones kind of set the 100, and then we kind of curve it from there on out. But that's not always the case. So sometimes everybody looks like junk, and we go 50% for everybody. And if 50% of your grade is based upon projects, and you turn in a whole bunch of janky ones, you end up with a deficit that's really hard to get back up. So I want you to really spend the time on projects. We care more about projects than we do about homework. We care about homework, but we care more about projects that you can actually physically do the things that you need to do. If you need more material, no problem at all. We've got plenty. I just put a whole bunch of it up last night. So we got plenty of material, everything that you need to do what you need to do. So, okay.
I was wondering if I could just, I don't know if I turned mine in or not, but if I did, can I get it back so I can use the bottom tab? I'll check my